I bet I can dial all the phone numbers in the world. Okay, so we're here to look at adding up resistors in a more complicated setup than just series or just parallel. How do we do them whenever they're mixed together? So let's just start by drawing a little circuit here. So here's my battery. Let's just say it's 40 volts. And then we come up here, we come over, come down. Here's a poorly drawn resistor. And then here's a branch where we come around like this, okay? So we've got a resistor here, R1, and it's equal to 25 ohms. And then down here we've got a resistor which is just 3 ohms, and then here this is 40 ohms. And as we see, we've got our little junction node point right here, which means that we have both in this setup a parallel branch and a potential series setup. So how do we go about doing this? What is the equivalent resistance of this system? So how do we go about doing this? Well, when we do this, what we always want to do is we want to kind of do this, it would be called like recursively in the world of computer science. We want to dive as many levels of parallel branches down as we can and then come backwards out of them. So in this example here, I don't want to just add 25 to 40 or 25 to 3. What I want to do is I want to take this parallel branch here and I want to turn it into just one equivalent resistor right here. So once I turn that into one equivalent resistor, what my circuit setup will look like is this, where this is the 25 ohm resistor we originally had, R1, and then this is the equivalent from that parallel branch. So I want to take this and put it there. Then once I have that, I'm going to have this nice series setup where I can just take 25 and add it to that and call it a day. So we always start as far deep, as many levels down into the parallel branches we need to go, and then we pull out from there, okay? So let's try to figure out what this parallel equivalent resistance is first. Well, we should remember that the equivalent resistance of things in parallel is each of these added together, the reciprocals of them, so like 1 over 3 plus 1 over 40. And if we take 1 over 3 plus 1 over 40, 1 over 3 plus 1 over 40, we get 0.358. But remember, this is 1 over that quantity, so I need to flip this. So 1 divided by 0.358 is going to give me about 2.79. So my equivalent resistance for just down here is 2.79 ohms, okay, or 2.8 if you want to round, whatever. So now, when we come over to here and we place this in, this right here is the 2.79 ohms. These are in series, and I can just add them together. So 25 plus 2.79 will just give me 27.79 ohms. And this is the equivalent resistance of the entire circuit. So now if I wanted to draw like the whole circuit, I could redraw it as here's the battery with 40 volts, and here is one resistor that has a resistance of 27.79 ohms. Okay? And this is very nice because now that we have it in this setup, we can say Ohm's law, V equals IR. We can say that 40 equals I times 27.79. Okay, so we get it into that final Ohm's law form for this by finding equivalent resistances. And the key to this is going down into the parallel branch to begin with, finding that equivalent resistance, being very, very careful that we're taking the reciprocal of that. And then once we have them together in one branch here, they're in series, and we can just add them together to get the full equivalent circuit with Ohm's law. Okay? So that's a quick little one there. Nothing too crazy. We'll get into some more devious things later on. So make sure you're checking out these circuit examples. But for right now, we are finished. Adios. Take it easy.